हेलो 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 हेलो। हेलो एवरीवन, वेलकम टू अन अकेडमी। तो आज की इस सेशन को स्टार्ट करने से पहले आप मेरे को कंकरेंस देंगे क्वालिटी ऑफ वीडियो और ऑडियो के बारे में। अन अकेडमी और यूट्यूब दोनों चैनल में साथ में लाइव हो रहा है। जो बच्चे जहां भी जुड़ रहे हैं एक बार मेरे को कंकरेंस दे दें, क्योंकि दो जगह लाइव होने में थोड़ा सा टेक्निकल मेरे को ज़्यादा मेहनत करना पड़ता है। सो दैट इज़ वाई आई हैव बीन टेकिंग द इनपुट हियर इटसेल्फ। एक बार बता दें और उसके बाद अपन क्लास स्टार्ट करते हैं। आज की क्लास का एजेंडा क्लियर होना चाहिए। आज हम लेने वाले हैं मॉस मॉस के न्यूमेरिकल सर्किट्स। सब परफेक्ट रहने के बाद रिप्लाई कर दें। अनंता आवाज सही आ रही है? अगर बता दो अनंता। चलो, प्रोबेबली सब चीज सही है। हेलो एवरीवन, वेलकम बैक। तो आज की क्लास का एजेंडा वही होगा जो पिछले 2 या 3 दिन से हम लोगों ने फॉलो किया है। न्यूमेरिकल्स लेने वाले हैं हम ई मॉसफेट पे। लिख के ले लो, इलेक्ट्रिकल इलेक्ट्रॉनिक्स इंस्ट्रूमेंटेशन किसी भी ब्रांच से हो, एक क्वेश्चन इस पर्टिकुलर टॉपिक से मिनिमम आएगा। इलेक्ट्रॉनिक्स वाले तो 3 क्वेश्चन, इवन 4 क्वेश्चन भी एक्सपेक्ट कर सकते हैं, डीसी और एसी एनालिसिस दोनों मिला के। मेरे को ध्यान है 2013 में लगभग लगभग 4 क्वेश्चन आए थे केवल मॉस डीसी एनालिसिस से, और एसी के एक आध क्वेश्चन और भी थे। तो सच ए इंपॉर्टेंट टॉपिक द मॉस टेक्नोलॉजी इट हैड बीन। ठीक है। डिवाइसेस में हो सकता है इससे कैपेसिटर के क्वेश्चंस पूछ ले, चैनल विड्थ मॉड्यूलेशंस के क्वेश्चन पूछ ले, बेस इफेक्ट का क्वेश्चन पूछ ले, तो वहां तो और भी वैरायटीज बनती है। चले, विदाउट फर्दर ड्यू, लेट मी टेक फ्यू नंबर ऑफ क्वेश्चंस ओवर योर कंप्यूटर स्क्रीन। देखिए, कुछ क्वेश्चंस मैं डिजाइन करके लाया हूं, है ना। और एक अकेले क्वेश्चन में मेरे को लगता है कि आप लोगों को अच्छा खासा आइडिया मिल जाएगा। क्यों? क्योंकि मैंने सर्किट वही रखा है, वीजी की वैल्यू चेंज की है और आरडी की वैल्यू चेंज की है। हो सकता है गिवन सर्किट केवल गिवन इनपुट्स के हिसाब से कभी कट ऑफ में चला जाए, कभी ऑन हो तो सेचुरेशन में चला जाए और ट्रायोड में चला जाए। ऑब्वियस ही बात है, तीनों कंडीशंस में यू आर गोइंग टू गेट द डिफरेंट डिफरेंट वैरायटीज ऑफ करंट आईडी। ठीक। देखें, द मॉसफेट इन बिलो फिगर, थ्रेशोल्ड वोल्टेज VT इज इक्वल्स टू 1 वोल्ट, म्यू एन सी ओ एक्स डब्ल्यू वाई एल रेशियो जो एक प्रोसेस पैरामीटर होता है, यह है 1 मिली एम्पियर पर वोल्ट स्क्वायर। डिटरमाइन द ड्रेन करंट इन मिली एम्पियर्स। मुझे ड्रेन करंट मिली एम्पियर्स में निकालना है, और यूजुअली प्रैक्टिकल वैल्यूज आपको ड्रेन करंट पे मिली एम्पियर्स में दिखेगी जब ये ट्रांजिस्टर ऑन हो। एंड द मोड ऑफ ऑपरेशन ऑफ द फॉलोइंग केसेस। फर्स्ट है VG इज इक्वल्स टू 0.5, RD इज इक्वल्स टू 1 किलो। सेकंड है VG इज इक्वल्स टू 2 वोल्ट, RD इज इक्वल्स टू 1 किलो। एंड थर्ड इज गोइंग टू बी VG इज इक्वल्स टू 2 वोल्ट, RD इज इक्वल्स टू 10 किलो। एक काम करता हूँ, इस पूरे के पूरे प्रॉब्लम को मैं लेके चलता हूँ वर्किंग बोर्ड पे थोड़ा बड़ा करके, और वहां आप लोग फटाफट मुझे आंसर करेंगे। चलें, so read the problem carefully and tell me what could have been the best most answer for this given question. Yeah. ये कुछ इस तरीके से। चलिए, क्या हो गया इसका? ये ये रहा आप लोगों का क्वेश्चन। ध्यान देंगे, ये ऑप्शंस नहीं है, ये प्योर क्वेश्चंस है। डेटा सबका सेम होने वाला है और कुछ 3 अलग अलग क्वेश्चंस में आप वीजी और आरडी की वैल्यूज चेंज कर रहे हैं। तो चलो, पहला क्वेश्चन आप लोग फटाफट रीड करो और इसका आंसर देने की कोशिश करना। और हर एक क्वेश्चन के लिए लगभग लगभग मैं 2 मिनट का टाइम देने वाला हूं। सो हियर कम्स द फर्स्ट क्वेश्चन, जहां वीजी की वैल्यू लगाई गई है 0.5, आरडी की वैल्यू लगाई गई है 1 किलो। So may I know what is supposed to be the ID current over here? I would like to know from each one of you. जो भी आंसर YouTube या अनअकैडमी एप्लीकेशन में देगा, पहले बगल में लिखेगा 1 और उसके बगल में आंसर देगा। अदरवाइज आई विल गेट कंफ्यूज्ड कि आप आंसर 1 के लिए दे रहे हैं, 2 के लिए दे रहे हैं या 3 के लिए दे रहे हैं। सो लेट्स स्टार्ट इट। ट्राई करो, बताओ आंसर कितना होने वाला है। स्टार्ट विद द फर्स्ट क्वेश्चन, देन वी विल मूव इट टू द सेकंड एंड एट लास्ट वी विल बी टेकिंग द थर्ड क्वेश्चन एज वेल। अनंता भाई बताएं आंसर क्या होगा। देखिए, ये है एनमॉस। एनमॉस ट्रांजिस्टर को स्टार्ट करने के लिए कम से कम VGS इतना एडिक्वेट होना चाहिए कि चैनल का इन्वर्जन हो जाए। VGS की वैल्यू ग्रेटर देन इक्वल्स टू ऑफ VTH होनी ही चाहिए, तब जाके कहीं ट्रांजिस्टर ऑन होगा। प्रॉब्लम में VGS देखेंगे तो VG जो है वो VG से कनेक्टेड है और सोर्स टर्मिनल ग्राउंडेड है, तो आप सीधे बोल सकते हैं VGS इज वेरी सेम एज VG। तो आप बोल सकते हैं कि जब जब VG की वैल्यू VTH से बड़ी होगी तब तब ट्रांजिस्टर ऑन होगा और आप एक सब्सटेंशियल आईडी करंट देख पाएंगे। सैचुरेशन में देख पाएंगे या ट्रायोड में देख पाएंगे, ये फर्दर इन्वेस्टिगेशन का सवाल है, बट आप करंट देख पाएंगे, दैट इज फॉर श्योर। लेकिन अगर आप इस प्रॉब्लम में देखेंगे फर्स्ट क्वेश्चन में, तो VG की वैल्यू है कितनी? 0.5। क्या ये बड़ी है VTH से? नहीं सर, VTH की वैल्यू यूनिफॉर्मली 1 वोल्ट दी हुई है। सो यू कैन सी वेरी वेल दिस इक्वेशन इज नॉट बीन मेट। तो एनमॉस जो है वो कट ऑफ रीजन पे है, ऑफ रीजन पे है। एनमॉस इज ऑफ और कट ऑफ रीजन। इसका मतलब डीप चैनल का निर्माण हो ही नहीं पाया है, जिससे इलेक्ट्रॉन सोर्स से होते 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 चैनल से होते हुए ड्रेन से लीव कर पाए। वर्चुअली स्पीकिंग, देयर हैड नॉट बीन अ प्रॉपर ड्रिफ्टिंग ऑफ electron and hence there had not been any drain current or source current. So may I know what is supposed to be the ID over here? So ID is simply going to be 0 in this given question. मैं ट्राई करूंगा ना केवल ID बल्कि VD VS इस तरीके के कैलकुलेशंस भी अपन परफॉर्म कर लेते हैं, जिससे जितनी भी अलग अलग वैरायटीज के क्वेश्चन इन फ्यूचर क्राफ्ट हो सकते हैं वो एक क्वेश्चन के पार्ट बन जाए। देखें, ID की वैल्यू तो निकल गई है 0। अगर ID 0 निकलेगी तो RD के अक्रॉस कुछ ड्रॉप नहीं होने वाला। भाई RD के अक्रॉस ड्रॉप क्या होगा? RD इंटू ID आपने 0 कर लिया है तो कुछ ड्रॉप नहीं होगा। सो ऑल द वे ये 3.3 वोल्ट जो है वो ड्रेन वोल्टेज बन जाएगा। तो कल के दिन प्रॉब्लम से पूछा जा सकता था व्हाट इज बीन द ड्रेन वोल्टेज यू एक्सपेक्ट फॉर दिस गिवन क्वेश्चन, तो आप बोलते 3.3 वोल्ट। अग्री कर पा रहे हैं सबके सब? यस सर। नेक्स्ट क्वेश्चन पूछा जा सकता था व्हाट इज बीन द VDS। VS तो ऑलरेडी 0 है, VD आपने अभी निकाला 3.3 है, तो अगर VDS निकालेंगे तो ये होगा VD माइनस ऑफ VS। VD है 3.3, VS है 0 और ये वैल्यू कितनी है? 3.3 वोल्ट। बात समझ में आ रही है? हाँ सर, दैट इज ऑल्सो परफेक्ट सर। कोई आपसे पूछ ले मॉस कितना पावर डिसिपिएट कर रहा है, तो मॉस में पावर का डिसिपिएशन होता है, चाहे वो एन मॉस हो या पी मॉस हो, अमाउंट ऑफ करंट विच इज बीन फ्लोइंग अक्रॉस ड्रेन टू सोर्स। तो अपन करंट आईडी ले रहे हैं और ड्रेन टू सोर्स वोल्टेज डिफरेंस जो है वो वीडीएस ले रहे हैं। आईडी जीरो है, वीडीएस नॉन जीरो है। जीरो और नॉन जीरो क्वांटिटी को अगर आपस में मल्टीप्लाई करेंगे तो आपको पता चलेगा ये ट्रांजिस्टर ऑन ही नहीं हुआ है, तो कोई भी पावर का कंजम्पशन नहीं कर रहा है। तो इस तरीके के तीन अलग अलग क्वेश्चंस आपसे क्राफ्ट करके पूछे जा सकते हैं। पहला क्वेश्चन हो सकता था कितना अमाउंट ऑफ करंट ड्रेन करंट बनेगा, ड्रेन वोल्टेज क्या होने वाला है, ड्रेन टू सोर्स वोल्टेज क्या होने वाला है, और इस एनमॉस में पावर का डिसिपेशन कितना होने वाला है। क्लियर है? आपने ऑलरेडी इससे पहले देख रखा है कि गेट करंट तो हमेशा जीरो होने वाला है, एनमॉस हो या पीमॉस हो, बिकॉज यहां सिलिकॉन डाइऑक्साइड का एक इंसुलेटिंग लेयर होता है जो कंडक्शन करंट अलाउ नहीं करेगा। अगर आप केसीएल लगाएंगे तो इस पूरे के पूरे मॉस से एक टाइम पे जितना करंट इंटर करेगा उतना ही लीव करेगा। तो यहाँ केवल एक करंट आईडी लीव कर रहा है तो वही लीव करेगा। हमेशा ध्यान देना आईडी और आईएस की वैल्यू एनमॉस और पीमॉस में सेम होने वाली है। एनमॉस और पीमॉस तो छोड़ दो, पूरे के पूरे एफईटीज में सेम होने वाली है, क्योंकि जेफेट में भी लगभग लगभग आईजी करंट बहुत कम होता है। इवन डी मॉसफेट में भी आईजी करंट बहुत मिनिमल होता है। तो यहां से आप एक चीज और भी बोल सकते थे, दिस इज ऑल्सो बीन द सेम एज आई एस। तो ये हाफ टाइम्स म्यू एन सी ओ एक्स डब्ल्यू बाई एल रेशियो, ये सब की यूज करने की इस प्रॉब्लम में नीड ही नहीं हुई। मुझे लगता है कि एक नंबर के लिए ये क्वेश्चन आसानी से किसी पीएसयू इसरो में पूछा जा सकता है, क्योंकि ना तो आप लोगों से बहुत ज्यादा चैलेंजिंग कैलकुलेशन कराया और ना ही कैलकुलेशन में बहुत ज्यादा टाइम स्पेंड कराया, क्योंकि लगभग पीएसयूज गवर्नमेंट ऑन्ड ऑर्गेनाइजेशन कैलकुलेटर तक तो अलाउ कर नहीं रही है। इसरो तो कंप्लीटली ऑफलाइन पेपर है, ऑफलाइन पेपर के साथ वो कैलकुलेटर अलाउ नहीं कर रही है। तो इसका सीधा सा मतलब ये है कि आपको कैलकुलेटर का एक्सेस तो किसी फॉर्म में भी नहीं होगा। यूजुअली गेट में आपको कैलकुलेटर अलाउ नहीं कर रही है, तो सीबीटी था, तो कम से कम कंप्यूटर में वो इनकनकेट एक कंप्यूटर कैलकुलेटर तो रख सकते थे। ये तो कंप्लीटली ऑफलाइन है। आगे बात समझ में यहाँ तक? मुझे नहीं लग रहा कि किसी को किसी भी तरीके की कोई भी इशू होनी चाहिए। Then we will talk about the next scenario. See what it states. VG is been 2 volt, which is quite larger than the value of VTH, जिससे चैनल का एक प्रॉपर डीप इन्वर्जन हो पाए, जिसके कारण आईडी करंट फ्लो हो सकता है। तो ट्रांजिस्टर आपने ऑन तो किया है, लेकिन अब आपको ये सोचना है कि ट्रांजिस्टर आपने सैचुरेशन में ऑन किया है या ट्रायोड में ऑन किया है। और साथ में आरडी की वैल्यू दी हुई है 1 किलो। व्हाट हैड बीन द वैल्यू ऑफ आरडी? आरडी इज बीन गिवन एज 1 किलो। और मुझे फिर से यहाँ आईडी की वैल्यू निकालनी है। हाउ विल आई गेट द वैल्यू ऑफ आईडी? दैट वी विल सी ओवर हियर। देखें, तो इस क्वेश्चन को सॉल्व करने का एक ही तरीका होता है, समझिएगा। VDS को आप VGS से कंपेयर करते हैं, वर्चुअली स्पीकिंग VD को VG से कंपेयर करते हैं। तो आप इस तरीके के प्रॉब्लम को अजम्पशन से ही स्टार्ट करेंगे। आप हमेशा ये मान के चलो अजम्पशन ये होने वाला है कि गिवन सिस्टम जो है वो सैचुरेशन में होने वाला है। अगर सैचुरेशन में होने वाला है तो आईडी सीधे सीधे VGS को फॉलो करेगा। इस तरीके से आप इस प्रॉब्लम को सॉल्व करें। लेकिन जब आरडी की वैल्यू निकल जाएगी, आईडी की वैल्यू निकल जाएगी, तो वीडी की भी वैल्यू निकल जाएगी। लेकिन उस समय आपको फिर ये चेक करना होगा कि वीडी की वैल्यू जो है वीजी से बड़ी है या नहीं है। अगर वीडी की वैल्यू वीजीएस वीजी माइनस ऑफ वीटीएच से बड़ी है या नहीं। अगर वीजी माइनस वीटीएच से बड़ी वीडी की वैल्यू हुई तब तो आपका एजम्पशन सही था और आपने जो सैचुरेशन का कैलकुलेशन किया था स्क्वायर लॉ से, दैट वाज ग्रेट। गुड मॉर्निंग डियर, दैट वाज ग्रेट। अदरवाइज यू आर गोइंग टू गेट मिस्टेक ओवर हियर। हैज इट बीन क्लियर? तो आप एक काम करें, वीजी की वैल्यू सबसे पहले 2 वोल्ट रखें, आरडी की वैल्यू यहाँ पर 1 किलो रखें और उसके बाद ये चेक करें कि आईडी करंट कितना आया है। ड्रॉप निकाल के आप ये देखें कि वीडी की वैल्यू कितनी आई है और वाकई में ये सेटिस्फाई हो रही है कि नहीं। तो ये इस तरीके के प्रॉब्लम को मैं एजम्पशन टेक्निक बोलता हूँ। क्या बोलता हूँ? एजम्पशन टेक्निक। भाई दो में से एक पॉसिबल था, या तो ट्रायोड और या फिर सैचुरेशन। तो स्टार्ट वहां से करें जहां से कैलकुलेशन आसान है। ट्रायोड रीजन में आईडी करंट का इक्वेशन अगर आप कनेक्ट करेंगे तो आप वीजीएस से भी कनेक्ट होता है और वीडीएस से भी कनेक्ट होता है। इक्वेशन अगर देखें तो ऑब्वियस सी बात है ट्रायोड रीजन में इक्वेशन थोड़ा खतरनाक है, तो अपन सैचुरेशन से ही ट्राई करेंगे। सैचुरेशन से ट्राई करने के लिए अपन वापस से आते हैं, आईडी इज इक्वल्स टू ये देखें, आईडी ड्रेन करंट इज इक्वल्स टू हाफ टाइम्स म्यू एन, दैट इज बीन द मोबिलिटी ऑफ n channel, COX, that has been the capacitance per unit area offered by the silicon dioxide layer, W by L ratio, and that has been width to length ratio of your channel। तो ये सब मिलके भी आपके आईडी को डिसाइड करती है। क्वाइट ओके। और एक बार अगर आपने मॉस डिजाइन कर लिया तो ये वैल्यूज चेंज नहीं होने वाली, इसलिए वो सब बोला जाता है इसको प्रोसेस पैरामीटर। तो जिस प्रोसेस से मॉस को बनाया गया होगा उस समय ये वैल्यूज डिसाइड हो चुकी होंगी। आगे बात समझ में यहां तक? तो चलिए सीधे डेटाज रखना चालू करेंगे। देखिए बस थोड़ा सा ध्यान रखना, कभी भी आप बड़े और कॉम्प्लेक्स कैलकुलेशन कर रहे हैं जिसमें खूब सारे पैरामीटर हैं, अगर एक एक डेटा एसआई का होगा ना तो रिजल्ट भी एसआई में आएगा। तो ट्राई ये करो कि आप यहां से म्यू एन सी यू एक्स जितने भी डेटास लेके आ रहे हो सब एसआई में हो। देखो क्या म्यू एन सी यू एक्स डब्ल्यू आई एल रेशियो, इस पे फोकस करने की नीड नहीं है। क्या ये एसआई है? बिल्कुल सर, करंट तो एसआई ही है, वोल्टेज भी एसआई है, बस ये जो मिली है ना इसको अपन अलग से एड्रेस कर लेंगे। बोले तो 1 की जगह में 1 इंटू 10 टू द पावर ऑफ -3 लेंगे। सब एसआई लेके चलो, अगर यूनिट्स के साथ यहाँ अगर आप कैलकुलेशन करना चालू करते हो तो अननेसेसरली ये पूरा का पूरा प्रॉब्लम जो है वो बल्कि हो जाएगा। क्वाइट ग्रेट सर। तो यहाँ क्या होने वाला देखें, हाफ टाइम्स ऑफ म्यू एन सी ओ एक्स, ये बिल्कुल सर 1 मिली है, डब्ल्यू बाई एल रेशियो, अरे डब्ल्यू बाई एल रेशियो तो ऑब्वियस सी बात इसका पार्टी बन गया है। ठीक, यहां आएगा VGS। देखो अगर इस प्रॉब्लम में देखेंगे VG का वैल्यू आपको ऑलरेडी पता है, व्हाट हैड बीन द वैल्यू ओवर हियर, VG की वैल्यू है 2 वोल्ट, सोर्स को आपने ऑलरेडी ग्राउंड कर रखा है, तो मैं बोलूंगा इसको 2, 1 से घटाने के बाद इसको मैं करूंगा स्क्वायर ऑफ, इसको करूंगा मैं स्क्वायर ऑफ। हैज इट बीन क्लियर टू ऑल ऑफ अस? हाँ सर। तो यहां से ID की वैल्यू कितनी निकलने वाली है ये देखें, व्हाट इज सपोज टू बी द वैल्यू ऑफ ID ओवर हियर, ID की वैल्यू क्या निकलने वाली है? ID की वैल्यू क्या निकलने वाली है, 2 में से 1 गया, और ये ध्यान देना ऐसा ही है तो मैं इसको 1 का स्क्वायर 1 ही मानूंगा। बस यहां आप देख लें कि ये आ रहा है 0.5 मिली एम्पियर्स। ID की वैल्यू शांति से आपने निकाल ली है 0.5 मिली एम्पियर। क्या ये सत्य आंसर है? अभी आपको स्क्रूटनाइज करना पड़ेगा कि वाकई में आपने जो एजम्पशन लिया था कि ये सैचुरेशन में ऑपरेट कर रहा है, ये कर भी रहा है या नहीं कर रहा है। तो उसके लिए क्या करेंगे, वापस से इस रिक्वायरमेंट को फुलफिल करेंगे। VD की वैल्यू VG माइनस VTH से बड़ी होनी चाहिए। बताएं VD की वैल्यू क्या होगी? ID की वैल्यू आपने 0.5 ऑलरेडी निकाल रखी है, देखो 0.5 मिली। RD की वैल्यू ऑलरेडी 1 किलो थी। 1 किलो को अगर 0.5 मिली से मल्टीप्लाई करें, किलो और मिली एक दूसरे को न्यूट्रलाइज करेंगे, 0.51 से मल्टीप्लाई होकर 0.5 वोल्ट बनाएगा। 3.3 को अगर 0.5 से सब्सट्रैक्ट करें, क्योंकि 3.3 का 0.5 वोल्ट तो यहाँ वैसे ही जाया गया है, वैसे ही ड्रॉप हो गया है, तो यहाँ जो वैल्यू पहुंचने वाली है वो 2.8 वोल्ट पहुंचने वाली है। तो मैं ड्रेन वोल्ट बोल सकता हूँ, ये है 2.8 वोल्ट। यस। उसके बाद आता है गेट वोल्टेज, ऑलरेडी 2 वोल्ट लिया हुआ है, और VTH ऑलरेडी 1 वोल्ट है। तो क्या 2.8 जो है वो 1 वोल्ट से बड़ा है? हाँ सर, 2.8 जो है वो 1 वोल्ट से बिल्कुल बड़ा है। और अगर ये बड़ा है तो इसका सीधा सा मतलब यही होता है कि आपने जो कैलकुलेशन किया है वो सत्य भी है। और ये किस रीजन पे ऑपरेट कर रहा है? दिस इज बीन वर्किंग इन कट ऑफ रीजन एंड दिस इज बीन वर्किंग इन saturation region. Saturation region. चलो एक बार बता दो, यहां तक सब लोगों को क्लियर है? फिर आगे बढ़ते हैं। Has it been clear to all of us? I would like to have the input from each one of you. Okay, about engineers. So what I would do, I would also try to explain the concept which we had delivered so far in English as well. See what I had done, I had taken a concept of MOS. Probably you might be able to see over here. We had a circuit which has been excited by a drain voltage of a 3.3 volt. It had a RD in series before connecting to the drain terminal. And again the gate terminal is being excited with the external battery of VG, and now the source has been grounded. Although we had only one circuit, but we had taken a 3 different kind of question, because I had seen, because most of the time in NMOS the student are not able to judge in which particular state the given NMOS has been operating. So what had been the question? The MOS in given below figure, threshold voltage is being given as a 1 volt. Mu n COX WIL ratio has been given as a 1 milliampere per volt square. Keep in mind it has been a process parameter. What does it mean by the process parameter? While the MOS is been getting fabricated, no, during that period of time, what are the different materials or the conditions are being used? They are going to be the deciding factor to this factor, and that is why it is being called as a process parameter. Determine the drain current in milliampere and mode of operation of the following cases. So this all are not in the different options. These are in the different questions itself. I had taken the first question where the value of VG is been 0.5 and RD is been 1 kilo. Keep in mind, MOSFET works in two different reasons. First, you had to make it on. If it has been off, obviously there would not be any current at all. Either it has been ID, either it has been IS. If it gets on, there would be a amount of current. The ID and IS is supposed to be non-zero. But now it can fall in two different categories. Either it could be in saturation region or in triode region. So mathematical relationship, mathematical targets through which I should know that whether it has been working in which region, that must be very clear to us. See, I had taken the first question. VGS until and unless is not greater than VTH, the MOS is not going to get turned on. As far as this problem is been concerned, gate terminal is been connected to the VG in first question. VG is been 0.5, whereas the source terminal has been connected to 0. So may I know what is supposed to be the VGS? That is supposed to be VG minus of VS. VG is been 0.5 and VS is been 0. So you can say this has been 0.5. Whereas in this MOS, the threshold voltage has been clearly given and that has been 1 volt. And you can see very well the 0.5 is not greater than 1. Virtually speaking, this MOS had not gone into the turned on condition. Why so? Because the inversion of the channel had not been taken place. NMOS or PMOS is a generally off kind of MOS. Until and unless the adequate amount of channel is not been penetrated, it won't get started. So that is why you can see very well the VGS is not quite enough such that there would be a penetration of a good channel and the transistor has been off. And as the transistor has been off, obviously there would not be any ID. ID and IS remains always same in any kind of FET. So if the ID is being 0, the IS is also being 0. What I say, even they may ask few more number of questions. They may also ask you to find the value of drain voltage. My dear friend, as there had not been any flow of current across the RD, so 1 kilo is been 1 kilo, but the amount of current which was flowing across this has been 0. So obviously I can say there had not been any drop. All the way this 3.3 volt becomes the voltage across the drain. So you can say the drain voltage has been 3.3 volt. The next important thing, they may also ask you to calculate the drain to source voltage difference. My dear friend, this has been a drain point and this has been a source point. Drain has been already kept at 3.3 volt, whereas the source has been physically grounded. So VDS is supposed to be VD minus of VS. VD has been 3.3, getting subtracted with 0 and the result has been 3.3. Even they may also ask you to get the amount of power which is been dissipated across this NMOS. So what is going to be the value over here? See, usually we take the power maximum gets drop across drain to source. Why drain to source? Because drain to source accumulates drain to gate as well as gate to source. That is why we take drain to source. Same goes with the BJT as well. If we say the amount of power dissipated across the BJT, what we do? We take VCE into IC. Because VCE takes the account of VCB as well as VBE. So as you can see very well, it is going to be a ID into VDS. VDS has been non-zero, but the ID was 0. And once you multiply them together, the result has been 0. The result has been 0. I had taken the reference of second variety of information, where the value of VG has been increased and increased in such that it had gone beyond VTH. Now, the value of VG has been greater than VTH, and probably there would be adequate penetration of inverting channel, and that is why there would be a flow of current from drain to source. Virtually speaking, your NMOS is on now. So for that, what I did, I have taken an assumption that the NMOS had started and it started in saturation region. Why? Because when the NMOS starts, there could have been the two different categories. Either it could have been started in the saturation region or the triode region. So what I did, I had taken the assumption that it had started in saturation region. Now many of the students would have a little bit doubt at this point, sir, why you had taken assumption? No, you can't calculate whether it has been working in saturation or triode until and unless you don't calculate the value of ID, because ID will tell you how much voltage has been dropped across the RD, will tell you the what had been the voltage across the drain, and from there only you can calculate whether it has been in saturation or not. So I had started taking it in saturation. I got the value of ID is 0.5, and yes, it had been satisfying my requirement. About engineer, has it been clear to you? Tell me, has it been clear to you or not? अनंता क्लियर है आपको? ओके डियर, नो इशू, वी विल यूज बोथ. नो, मैं हिंदी में भी पढ़ाऊंगा एंड मीनवाइल आई वुड आल्सो स्पीक इन इंग्लिश एज वेल, सो द हिंदी लर्नर दे विल बी कीप राइटिंग and the English learners like you, definitely we will be able to learn the thing very well. Learn the thing very well. अनंत एक चीज बताएंगे मेरे को, जो वीडियो जा रही है अपने कहाँ, अनअकैडमी एप्लीकेशन में, वहाँ वॉइस मॉड्यूलेशन में कोई दिक्कत है क्या? Because in YouTube I don't find that problem has been persisting, but probably there we had the problem. So now what we have been doing, we had been taking the next question as well, and keep in mind the today's lecture and the lecture which is supposed to come in tomorrow's class, we had been completely dedicated. ठीक है, ठीक है, हाँ, we will use both, we will both use both. Okay, so here comes the next question as well. See, this kind of the questions are been the pet questions in your GATE examination. और ध्यान देंगे इसरो वगैरह में इस तरीके के क्वेश्चन थोड़े कम एक्सपेक्टेड है. रीजन भी है क्योंकि कैलकुलेटर इज नॉट बीन अलाउड in ISRO. The calculator is not been allowed, so whatever the calculation is to be made, it has to be made using manual pen and copy as only. So चलिए एक अगला क्वेश्चन लेते हैं, देखिए क्या लिखा हुआ है. What had been clearly written in this given question? The transistor in below figure has VT, mu and COX. Determine the drain voltage. Determine the drain voltage. Okay, Vs value has been given or not. What we will do, we will take first few of these straight questions which are already been the part of gate. In this problem. So let me take this problem first. So what I am going to do over here, all of the simple kind of the questions जिसमें आप सीधे अपना approach use कर लेंगे, where you can easily digest the concept which I am been telling over here. We will take those questions in a first slot. Yeah. So here goes the first question. Read the problem carefully and tell me what could have been the best most answer. Problem को ढंग से read करेंगे और ये बताएंगे कि इस problem का सबसे सार्थक आंसर क्या हो सकता है. The parameter of a transistor, keep in mind either it is been a BJT, D MOSFET, E MOSFET or JFET. They all are been in category of transistor. So do not get confused कि सर यहाँ transistor क्या लिखा है. Why the word transistor is been used? Transistor word had come from transfer the resistor. Almost all kind of different devices which can work as an amplifier usually works on the feature of transfer the resistor, and that is why it is been called as a transistor. Either it has been BJT, JFET, E MOSFET or D MOSFET. It can also be called as a transistor only. VTN लिखा हुआ है, so don't get confused. VT stands for threshold voltage, N stands for the NMOS, because the device which we had used in this circuit is nothing but a kind of NMOS. Again, the process parameter has been clearly given, and what had been that? Half times of mu n COX W by L ratio, and that had been given as a 0.5 milliampere per volt square. 0.5 milli per volt square, and lambda is equals to 0. Anyways, lambda is also been an important factor जो बहुत कम जगह impact आता है. Rarely you will see that the lambda will have the impact in your question, but when the lambda will have your impact, definitely there would be a little bit change as well as the complexity in your calculation. So wherever the lambda is not been given, you just neglect the channel length modulation effect. Just neglect the channel length modulation effect. And here exclusively it had been given that the lambda is being 0. Virtually speaking, the channel length modulation effect is to be dropped. The value of VDS is to be calculated. Again, the same kind of question, my dear friend. Source is already been grounded. So VDS is nothing but drain voltage minus of source voltage. Source voltage is already been 0. So our VDS has been very same as a drain voltage itself. Drain voltage itself. Has it been clear to all of us? Yes. So let me take a graph for the better understanding what I am saying. Let's take it has been a output voltage to current characteristic for NMOS. So output voltage would be taken across VD, and the current is nothing but ID. Anyways, ID and IS has been very same. So if you want, you can take IS as well. No issue. When the NMOS has been on, you will see the VDS and ID is being connected through this graph. It's been a kind of this. It's been a kind of this. Yes. Theoretically, we take the outcome is like this. But practically you will see this flat region, which we also call the saturation region, the ID is not been completely independent from VDS, or virtually speaking, there had been a minute increase in ID as the value of VDS increases. What does it actually mean of it? That means in saturation region, ID केवल VGS पे dependent नहीं होगा. It would also have a little bit dependency over the VDS. So what used to be the current equation? The current equation has been ID is equals to half times of mu n COX W by L ratio. Keep in mind, if we take this flat region, one thing has been quite sure. In this flat region, ID has been completely independent from VDS. It is only has to do with VGS, because this different graphs we had made, no, they are been the different values of VGS. So here goes VGS minus of VTH, and ID and VGS has been connected with a square law. So इसका होता है ये square, ये इसका होता है square. Has it been clear to all of us? Now it gets multiplied with the 1 plus lambda VDS. When it gets multiplied with the 1 plus lambda VDS, when it is being seen the ID is also having a little bit impact from the VDS. And if we neglect that impact, I keep lambda as 0, and as I keep lambda as 0, by default the same equation has been prevalent. So मैं सबसे जानना चाहूंगा about engineer and Ananta Khanna. इस प्रॉब्लम में should I drop this component or should I keep this component? मैं आप दोनों से जानना चाहूंगा. Should I drop this component or should I keep this component? This one. Tell me. बताते जाएंगे. Should I drop this component or should I keep this component? इस component को रहने दो. 1 plus lambda VDS को इसको drop करूं. Obviously. तो इसको अपन drop कर रहे हैं. Why? Because the value of lambda is been taken as 0 over here. And as the value of lambda is been taken 0 over here, we can web off. The next important thing, drop. Correct. Drop. Yes. So what I'm saying, in the given problem, if nowhere the lambda has been discussed, the value of lambda has not been given. So you have to do one thing. You have to drop this term, and this is going to be the current equation. But this current equation has been valid only and only if your transistor or the MOS has been working in saturation region. Okay. So we'll come back to this question. My dear friend, what has been the need? See, try to understand. What has been the need of keeping your NMOS in saturation region? You had to fulfill this criteria. Drain to source potential difference has to be greater than gate to source potential difference minus the threshold voltage for the given NMOS. Quite okay. VDS could have been written as VD minus of VS. VGS could have been written as VG minus of VS. Anyways, minus VS and minus VS had been cancelled in left hand side as well as right hand side both. Quite okay, sir. It has been subtracted. Now we can see very well what has been VD over here, what is VG over here. In this given question, drain and gate terminal are being short circuited. So whatever the value would be at drain terminal would be same at gate terminal. तो VD और VG जो है वो क्या होगा, सेम होगा. बिल्कुल सही है सर. तो अगर VD और VG सेम होगा, let's take VD has been 2 volt, it is just been assumption, so it is going to be of 2 volt minus what has been VTH has been minus 1 by 2. So can't we say that 2 is been greater than 0.8? हाँ सर बिल्कुल है, 2 is been greater than 0.8. So about engineers, have a look one thing. Whenever drain to gate terminal has been short circuited, if the given MOS is been on, I'm not saying it has been on or off. If it has been on, by default it would get on in saturation region. Why? Because VD will always be greater than what has been VG over here. In this given question, VG is also been VD. So VD will always be greater than VD minus of VTH, no? Yes. Like if I say 2 is been greater than 2 minus 1, obviously it would be, because again you had been subtracting something from 2. So obviously it would be lesser than its on value. So from here onwards, at least I can say one thing, कि जब भी drain and gate terminal get short circuited, if the MOS starts, it will always get started in saturation region. Agreed? So it has been in a saturation region. We had already seen the gate terminal is not going to sink any amount of current. Why? Because the gate terminal and channel terminal, in between there had been a layer of silicon dioxide, which has been a khatarnak type of insulator. Conduction current is not been allowed. Okay, Swami, did you understand what exactly I wanted to communicate? Yeah, great. So Swami, what I am saying, the gate terminal will not sink any amount of current, and as the gate terminal will not be able to sink any amount of current, what would happen? All the way this 50 microampere current becomes the current across the drain itself. Yes, drain itself. So what I would do, I would keep this ID as 50 micros. Quite okay, sir. Half times of mu n COX WIL ratio, each and everything is been given, but that had been given as a 0.5 milli. Great, sir. Source is already been grounded. Gate terminal is nothing but the voltage across the drain terminal, and in this question what they had asked, VD only. VDS minus of VTH. VTH is how much? 1.2 raised to the power of 2. Raised to the power of 2. Agreed till this point? So what I would do, see, 50 will be divided with a 0.5, that would make it 500. Micro and milli would become milli. So here it becomes 500, 500, 500, 500, and here comes millis, 500 millis. I need to decide the value of VDS minus of 1.2. My dear friend, always use heat and trial method over here. Why? Because unnecessarily you'll expand it, it would become a quadratic equation. So I don't want to deal with the quadratic equation. I would also always try to keep the mathematics as simple as, and most of the time, linear equation. So which value will satisfy this requirement? Tell me, which value will satisfy this requirement? Anyways, D can't be the answer at any cost. Tell me, Ananta, kya raha answer? 1.52 minus of 1.2. Once we'll subtract them, so value is supposed to be 1 and 1 goes off, and that becomes 0.30. You'll be getting the answer somewhere. And let me see what had been the answer over here. Answer you can get it by yourself. Answer you can get it by yourself, because the calculator I don't have over here. B aa raha hai na? B. So that would be the answer over here. Anyways, the complete calculation which we were made over here, no, it has been out probably. Yes. Yes. Swami, did you calculate it? Calculate and probably. Okay, B has been the answer, 1.52. Let me check it out. 1.52. .52 gets subtracted with a 1.2, and we will take it square. Check it out, check it out. So here comes 1 point. We will start doing the calculation for the each and individual option. 1.69 minus of 1.2, and then we will take a square of. The value is been somewhere 240 millis. No, obviously it can't be the answer. Then we will take the reference of 1.52. 1.52 minus of 1.2, and we will take its square. The value is somewhere 102 milliamperes. I want the current to be 500 milliamperes. No? Then we will keep 1.84. 1.84 minus of 1.2, and then we will take the square. C has been the answer, my dear. C has been the answer. No, it is not B, it is C. I want the 500 millis, no? So I want the subtraction of VDS minus of 1.2 somewhere here. So what is going to be the VDS over here? Approximately I can say it has been 1.84. Ananta, एक बार और फिर से try करें. Swami, you also tell me which answer you have got it for this given question. I want the answer from each one of you. And I would request to each one of you, try to attend my regular basis classes. Either it has been morning, either it has been evening. So either you are been from comfortable in Hindi or English, because I can communicate in both, so you will be comfortable, no issue. अनंता भाई अगर चेक करो, बताओ आंसर क्या आ रहा है। बी के लिए तो ये आ रहा है 102 मिली एम्पियर, ऑल्दो 1.84 के लिए भी एग्जैक्ट नहीं आ रहा है, लेकिन हाँ उसके लगभग लगभग आ रहा है, जीरो तो हो ही नहीं सकता। चले, सो वी विल टेक द नेक्स्ट स्लाइड एज वेल। So why don't we take a next question as well? And here they had been talking about the power dissipation, the amount of power which is getting dissipated across the given NMOS. We had already seen the power dissipation across the NMOS or PMOS is being the multiplication between the voltage between drain to source terminal into the amount of drain current which has been experienced, VDS into ID. जैसा कि अपन ने इससे पहले बीजेटी में पढ़ा था, बीजेटी के अक्रॉस पावर ड्रॉप बोला जाता था, आउटपुट आप कलेक्टर और इमीटर के बीच में लेते थे और करंट होता था आईसी। वैसे ही अब यहां पर एनमॉस में आउटपुट ऑफ ड्रेन और सोर्स के बीच में ले रहे हैं, करंट है आईडी। सो देयर इट वाज VC into IC in case of BJT, but in case of NMOS it is going to be of VDS into ID. So here comes the next question. Have a look on this question and tell me what could have been the best most answer. बी अगर चेक करो ना कैसे आ रहा है यार, बी नहीं आ रहा है ना, बी कैसे आ रहा है बताओ मेरे को। मेरे को 500 मिली चाहिए ना, बाकी सब डेटा को तो मैं इधर ट्रांसफर कर चुका हूं। यस, ओके 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 ओके, बताओ ना तो ये दिस इज नॉट 500, दिस इज बीन 100. See why? Because the 5 and 5 is also going to get demolished, no? So 50 is going to get divided with 0.1 and that has been 100 now. And now I can say the B has been the answer. B has been the answer. Okay, 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 that's fine, that's fine. Okay then, so here comes the next question. Read the problem carefully and I would like to have the input from each one of you. Tell me what has been the expected power dissipation across MOS only. I had been taking the reference of MOS only. Read the problem carefully and tell me what is supposed to be the best most answer. And I would request to each one of you, the student who had been joining through Unacademy application, this should also be quite active. This should also be quite active. Tell me what would be the best most answer for this given question. I would like to have the input from each one of you, the student who have been the part of Unacademy application or who have been watching me in YouTube. So I want the input from each one of you. I want to calculate the amount of power which is being dissipated across this given NMOS. And that has been the question of this Okay, Swami, I'll try that as well. Sir, I watched your classes of control and maths. They are very good. Can you complete EMFT and communication in English in YouTube itself in just 30 hours? Obviously, I'll try. I'll try that as well. Or I can do one thing. Even in main channel, if we'll try to spend some time, no, we will teach in both. Hindi भी use कर लूँगा. I'll use Hindi as well as English both. Swami, from which particular state you belongs from? Tell me. Anyways, my dear friend, as far as this problem is been concerned, nowhere the 0 milliwatt is been given. What does it actually mean of it? Can you tell somebody? Anybody? What? Nowhere the options are been given as a 0 milliwatt. That means this transistor has been on. If this transistor would be off, okay, AP, that's great. If this transistor has been off, the current across this transistor must have been 0, and as the current across this transistor must have been 0, the power dissipation would have been 0. Okay. Has it been clear? So coastal region or non-coastal region? So one thing has been quite sure, you don't have to worry whether this transistor has been on or not. It has been quite definite that the transistor has been on. So that is what few of the important conclusion I would like to deduce over here. In option, nowhere 0 milliwatt is been written. What does that actually mean of it? That means the transistor has been on. Exactly, I won't be able to tell whether it has been on in saturation or triode region, but it has been on. It has been on. Quite okay, sir. Even the process parameters like threshold voltages, half times of mu n COX W by L ratios are clearly given in this problem. It had exclusively seen in the last problem, when gate and drain is been short circuited, the given MOS, if it is on, by default gets on in saturation region. ठीक, आ गई बात समझ में? तो कहां से हैं आप? खाम्बम डिस्ट्रिक्ट से। देख लेते हैं ना, देख लेते हैं। तो ये क्लियर हो गया कि इट इज बीन ऑन, बाय डिफॉल्ट इट इज बीन ऑन एंड ऑन इन सैचुरेशन रीजन। हाउ डिड आई नो दैट इज बीन इन सैचुरेशन रीजन? क्योंकि आप देख सकते हैं कि ड्रेन एंड गेट इज बीन kept at a same potential. Whenever this has been a case, either it is in PMOS, either it is in NMOS, by default the MOS it starts in saturation region only. Saturation region में ही start होता है. Great sir. ID की वैल्यू क्या आएगी? ID की वैल्यू क्या आएगी? हाफ टाइम्स ऑफ mu n COX W by L ratio. Nowhere the lambda is being given over here. Lambda का कहीं भी कोई डिस्कस नहीं हुआ है. इसका मतलब ओके आनंदपुर चैनल लेंथ मॉड्यूलेशन को अपन ने नेग्लेक्ट किया है, as we have done it in the last two question. So here comes VGS. May you know what is been VGS over here, my dear friend? See, VG is all the way 10 volt because VG has been connected to the drain terminal and drain terminal is all the way connected to the 10 volt. My dear friend, अगर इसके बीच में कोई रेजिस्टेंस होता, if this terminal and this terminal must have possessed a certain resistance, in that case both potential would not be same because there had been a flow of current. फ्लो ऑफ करंट तो है ना यहाँ पर? हाँ सर, फ्लो ऑफ करंट तो है. फ्लो ऑफ करंट के कारण यहाँ ड्रॉप भी आएगा एंड बिकॉज ऑफ दैट ड्रॉप 10 वोल्ट वुड नॉट कम ओवर हियर. एनीवेज हियर कम्स VG, that has been 10 minus of VS minus, and what had been the value over here, and that has been 2, and that has been raised to the power of 2. That had been raised to the power of 2. Has it been clear to all of us? और कुछ दिया हुआ है कि देखो यहाँ पर anything else is being given over here? No. See, in this given question, as you can see very well, the ID and VS are being the two different components which had come together. Yes sir, which has come together. So what to do in that case? Do we have any relativity between ID and VS? Yes sir. The ID current has been a current which was flowing across the drain terminal, but as the gate does not sink any amount of current, ये भी drain current ही होगा. और चूंकि गेट से कोई करंट फ्लो नहीं होगा तो ये भी ड्रेन करंट ही होगा. So at least the source voltage can also be connected with the drain current. Agree कर रहे हैं? Are you been agreeing on this point? So what we will do, we will try to keep that as well. So here ID is nothing but either I can write Vs is equals to what? 10 kilo into of ID, 10 kilo of ID, or you can write either of them. So whatever you want, you can do it over here. So चलो फटाफट ट्राई करो और बताओ कि आंसर क्या होने वाला है. What is supposed to be the answer over this given question? So what I would do in this question, just try to understand in this way. I will keep ID as ID. Great, sir. Half times of mu and COX WIL ratio has been clearly known. Yes, sir. And that has been 0.2 micro. Then comes 10 minus of Vs minus of 2. 10 minus of 2, that becomes 8. That is okay, sir. What has been Vs? Vs is nothing but the 10 kilo into ID. And that had been raised to the power of 2. And I can smell your pain कि ये 10 किलो ID और उसके बाद एक quadratic equation. How will I solve this problem out? The best way. Just try to understand this way. आंसर में क्या लिखा हुआ है? मिलीवॉट्स. समझना क्या बोल रहा हूँ मैं. आंसर में क्या लिखा हुआ है? मिलीवॉट्स अगर आंसर में लिखा हुआ है और वोल्टेज आ रहा है वोल्ट्स में. अरे आंसर किस में आ रहा है? वोल्ट्स में. जैसे 10 वोल्ट से कुछ घट के यहाँ पर आया, वोल्ट्स में आया. सो वर्चुअली ID probably must be coming in millis. And you can see very well either it is in BJT, either it is in MOS. आप चाहे वहां पर इमीटर करंट देख लें, यहाँ पर ड्रेन करंट देख लें, ये जनरली मिलीज में आता है. So what I am going to do over here, that you have to understand now. I had taken ID in X millis. ID is being taken as X millis. Because once you'll do so, now the calculation would be much easy. So instant the ID I had fed X milli is equals to 0.2 micro. And then comes 8. And you yourself would be able to see now, ID is been X milli, milli and kilo goes out, and here it becomes minus of 10x. And now it had been raised to the power of 2. Agreed? So here, you yourself would be able to understand, milli and micro goes out. If you want, if you'll shift this value over here, so it becomes x divided by of 0.2. This micro will come towards downside, milli is already there. It is going to be of 10 to the power of 3. And here comes 8 minus of 10x to the power of 2. 10x to the power of 2. Yes. So here it becomes 8 minus of 10x raised to the power of 2. You could have written this as a 10 must have been taken out, and 10 divided by 0.2, it is supposed to be how much? 50. So here it becomes 50x. But from here onwards you have to use the calculator. What I am saying, from here onwards you have to use the calculator. So what I am saying, you don't get confused because this kind of questions you won't be able to solve. You had to solve over here, no issue. आप यहाँ से x की value निकालेंगे, you will be getting the two different values of x. You had to select the appropriate values. How did I select the appropriate value? Wherever the value of ID is been negative, definitely it has to be discarded. And wherever the value of ID is been positive, I will be using that out. So calculate this, how much answer we have been getting. We will try to calculate that as well. So let me bring a tab. With the help of that, I would be able to say something. चलो ना, यहाँ पर कैलकुलेटर वगैरह नहीं है मेरे पास. अनंता कैलकुलेट करें. आएगा ना क्वाड्रेटिक इक्वेशन, और इस तरीके के क्वेश्चन गेट में नहीं आएंगे. हो सकता है गेट में यही पूछ ले कि किस क्वाड्रेटिक इक्वेशन को फॉलो कर रहा है. विच क्वाड्रेटिक इक्वेशन इज बीन फॉलोड बाय दिस गिवन क्वेश्चन. इन गेट दे कैन आस्क एनीथिंग. नो, दे कैन आस्क एनीथिंग. ये क्वाड्रेटिक इक्वेशन अपने कैलकुलेटर से सॉल्व करो एंड गेट द वैल्यू ऑफ एक्स. नाउ anyways we will feed milli over here. Once we get the value of ID, we can calculate each and everything. Has it been clear? Swami, आपको क्लियर है? Has it been clear, Swami? And what about the Ananta? Has it been clear or not? That you tell me. (1.02 milliampere. अच्छे से calculate करना. If it has been 1.02 milliampere, so this has been 10 volt. 1.02 milliampere that has been told by Ananta. And now it gets multiplied with the 10 kilo as well. 10 kilo as well. गलत है, गलत है, गलत है, गलत है. तो कोई दूसरा ट्राई करो. दो वैल्यूज आएंगी इसकी. You'll be having two positive values. Why I'm saying, if you'll take the amount of current has been 1.02, again it will flow across the 10 kilo, and 10 kilo into 1.02 will exceed the value at drain itself. So this would be the case where the drain terminal has been at a lower potential and the source terminal has been kept at a higher potential. That could not be the case. हाँ, अब बताओ अनंत, अब सही आया है कि नहीं? देखो अब ध्यान देंगे स्वामी जी. You also have a look on it. While solving this problem, as Ananta says, there had been the two different answers. Both had been positive. But how will I know that which has been a correct one and which has been a wrong one? 0.623. See, if you take first as an option, this current flows across this as well as this. So 1.02 milli gets multiplied with the 10 kilo. The multiplication would be greater than 10 volt. If the multiplication has been greater than 10 volt, virtually speaking, source potential has been kept higher than the drain terminal, which is not been the case. It had already been seen in the last class. In case of NMOS, drain potential will always be greater than the source potential. This is been completely neglected. Ananta bhai, has it been clear? Has it been clear? So you will take the reference of 0.623 only. So yes, kilo and milli goes out. And here somewhere you will be getting the voltage as 6.23 millivolt, kilovolt, volt, and here it is been 10. So virtually speaking, here we get 10 minus 6.23, 10 minus 6.23, that is been this, and gets multiplied with, just a minute, 10 minus 6.23. Quite great. And again the current is been 0.623 and the value is somewhere 2.35. Ananta, मजेदार क्वेश्चन था कि नहीं ये बताएं. Now you have been getting the answer as a 2.35. Although it has been a complex question, although you won't expect this question in ISRO or GATE, but what I say, if you go through this kind of process, no, you grill yourself and you becomes a better person in engineering. You becomes a better person in engineering. Has it been clear to all of us? If you want, I can show you once again. I don't want all of the stuffs. I will just keep all of the stuffs which have been important. Obviously, it has been on. It has been on. Yes, remove this. Remove this. We had started from here. ID is equals to mu n COX W by L ratio. Quite okay, sir. See, we had started from here. I don't know ID, but I know this value. I know this value, but here what I did, deliberately the VS has been kept as ID. नहीं वो ठीक है ना, ये निकाल के दिया है, देखो अगर दिखा देता हूँ ना, 0.2 माइक्रोस. देखो अब इस प्रॉब्लम में दिक्कत क्या आ रही थी? द दिक्कत वाज हियर वी हैड बीन डीलिंग विद द किलोज इन रेजिस्टेंस. So making the quadratic equation dealing with kilo would become very difficult. So deliberately I kept ID is milli. So though advantage we got it. First advantage, kilos and millis are going to get smashed, and now this milli and micro becomes kilos. Agreed? So easily you can get the value now. So yes, we had made a quadratic equation. We got the value of x. X जो निकाले हैं उसके सामने मिलीज लगाना होगा. 1.02 I had left it out as it is. Why? Because obviously this is making the source terminal voltage greater than drain terminal. Yes, we had left it. We had gone through this. अगर आप इसके थ्रू जाएंगे तो आप ये देखें कि what is VD over here. VD is been 10 volt. Great, sir. What has been VS? VS is nothing but 10 kilo, and the amount of current which has been flowing across it, it has been 0.623 millis. Once we'll multiply them, kilo and milli goes out, and that has been 6.23. Quite okay, sir. Anyways, the power drop across the transistor is supposed to be VDS into ID. What has been VDS over here? The 10 would be subtracted with the 6.23. 10 would be subtracted with 6.23, and that has been 3.77. 3.77. Yes, and the amount of current ID which has been flowing is nothing but 0.623 millis. ये देखो, अब मल्टीप्लाई करो, 0.623 मिलीस, ये वैल्यू कितनी आ रही है देखें, 2.34 आ तो रहा है। ये क्या दिक्कत है अनंत इसमें?